Good morning, everyone. My name is Afreen. I am of CSIT A section. Today, I'm going to discuss my topic algorithm design. Introduction to algorithm. Algorithm design is a process of creating a set of instructions or an algorithm to solve a specific problem. It is an essential skill of computer scientists and programmers, as it allows them to create efficient and effective solution to a common problems. Problem statement. Problem statement algorithm design is a crucial aspect of a computer science that involves developing efficient and effective algorithms to solve complex problems. The problem statement is the first step of the algorithm design process, as it defines the problem that needs to be solved and provides a clear understanding of the requirements and constraints that must be considered when designing the algorithm. The problem statement should clearly define the inputs and outputs of an algorithm, as well as the specific requirements or constraints that must be considered. It should also consider the time space complexity of the algorithm, as well as a potential trade-offs that maybe need to be made between efficient and accuracy. Paradigms. Paradigms. Algorithmic paradigms are a set of techniques that are used to solve computational problems. By understanding these paradigms, we can develop more efficient algorithm that can solve complex problems in a shorter amount of time. In this section, we will discuss some of the most common algorithmic paradigms used in algorithm design. Dynamic programming. The dynamic programming paradigms involves breaking a problem down into a smaller sub-problem and solving this sub-problem in a bottom-up manner, using the solution of a sub-problem to find the solution to the original problem. This approach is often used for optimization problems, whereas the goal is to find best solution from a set of possible solutions. Divided and conquer. The divide and conquer paradigmic gimmick involves breaking a problem down into a smaller sub problem, solving these sub problems recursively and then combining the solutions to the sub problems to solve the original problem. This approach is often used for problems that can be divided into smaller independent sub problems. Greedy. The greedy paradigm involves into the local optimal choice at each step. The hope finding a global optimum, the approach often used for optimized problems, whereas goals is to find the best solution from a set of possible solutions. Divine and conquer. A divine and conquer is a common algorithm design technique used to solve complex problems that the basic idea behind this technique is to break a problem down into a smaller, more manageable subproblem and solve each subproblem separately. Once all the subproblems have been solved, the solutions are combined to solve the original problem. The divide or conquer technique is particularly used for problem problems that can be broken down into identical or similar subproblems. It is also used for problems that can be solved recursively. Recursively algorithms that repeatedly applies the same procedure to the smaller and smaller instance of a problem until the problem becomes smaller enough to solve directly. One example of problem that can be solved using the divide and conquer technique is sorting. To sort a list of items, the list can be divided into two smaller lists. Sort the list at a smaller list and which is sorted separately. The two sorted list can then be merged into a procedure to final sort list. This procedure can be repeated recursively until the entire list is sorted. Greedy algorithm. Greedy algorithm are a type of algorithmic design technique that makes the local optimal choice each step with the hope of the finding a global optimum. These algorithms are often used for optimization of a problem where the goal is to find the best solution for a set of possible solutions. How greedy algorithm works. A greedy algorithm worked by making the local optimal choice at each step with the hope of finding a global optimum. At each step, the algorithm chooses the optimum which provides that most immediate benefit without considering the long term consequences. This can lead to suboptimal solution that is but may in many cases it is effective to find solution quickly. Examples of greedy algorithms. Some examples of problems that can be solved using greedy algorithm includes minimum spanning tree problem, that snaps problem, and traveling salesman problem. In each these cases, the greedy algorithm makes the local optimal choice at each step with the hope of finding a global optimum. Dynamic programming. Dynamic programming is a technique used for algorithm design to solve complex problems by breaking them down into a smaller subproblems and solving each subproblem only once. This approach can scientifically reduce the time and the space complexity of an algorithm, making it more efficient and scalable. Dynamic programming is based on the idea of overlapping subprograms where the solution to a subproblem is multiplies times solving the main problem. The technique involves storing the solutions to a subproblem is a table in a table so that they can be looked up and reused when needed. Dynamic programming can be applied to a wide range of problems, including optimized sequence alignment and graph traversal. Backtracking is an algorithm design technique that can be used to solve problems by incrementally building a solution and then undoing the last decision if it leads to a dead end. The technique is useful when there are many possible solutions to a problem and finding the right one to request for exploring many paths. Applications of backtracking can be used to solve a variety of problems, including Enquine's problem, that snack problem, and the traveling salesman problem. It can be used to generate all the possible permutations or a combination of a set of elements. Backtracking algorithm Backtracking algorithm can be implemented using recursion at the each step. The algorithm checks its current solution is valid, and if it is, then it continues to the next step. If the current solution is not valid, it backtracks to previous steps and tries a different solution. In order to design efficient algorithms, there are several techniques that can be employed. These includes divided and conquered and dynamic programming. Algorithm analysis. Algorithm analyze this process for evaluating the efficient and performance of algorithm. It involves in analyzing the time and space complexity of an algorithm and determine the how efficient it is used for computing resources. Time complexity, this refers to the amount of time it takes for algorithm to complete its task. It is usually measured in terms of the number of operations performed by the algorithm and denoted by the big O of notation. Space complexity, this refers to the amount of memory or a storage space required by an algorithm to complete its task. It is also measured in the terms of number of operations performed by the algorithm and is denoted by big O notation. Asymptotation is a mathematical notation used to describe and limiting behavior of a function as an input size tends towards the infinity. The commonly used algorithm analyzing to describe the performance of an algorithm as input size grows. There are three main types of asymptotation: big O, big omega, and a big O theta. Big O notation you use to describe the upper bound of the function. It provides estimate the worst case scenario for the performance of algorithm. For example, algorithm has time complexity on big O of n. It means that running time of the algorithm will grow at a most linearly with the input size. Big omega notation is that describes the lower bound of a function is provides the estimated best case scenario. The performance is an algorithm. For example, for algorithm has time complexity of omega n, big omega n, it means the running time for algorithm is grown at least linearly with the input size. Big theta notation Big theta notation is used to describe both uppercase and a lowercase bound of a function. It provides an estimated of average case scenarios for the performance of algorithm. For example, if an algorithm has a time complexity of big theta n, it means that running time of an algorithm will go linearly with the input size. Time complexity is a measure of the amount of time taken by an algorithm to run as a function of a size of input. It is important aspect of an algorithm analysis as it helps us to understand how efficient an algorithm is in the term of taken or executable to the time complexity for an algorithm usually expressed in the big O of notation. Space complexity in algorithm analyzing space complexity refers to the amount of memory required by an algorithm to solve a problem. This includes this includes both the amount of memory required for an input data and amount of memory required for algorithm itself. Space complexity is an important consideration in algorithm design, particularly for algorithms and process large amount of data or have limited memory. Conclusion. In conclusion, algorithm design is complex and critical aspects of a computer science. By understanding the principle of algorithm design, we can create more efficient efficient algorithms that solve real world problems. We have converted a wide range of topics in the presentation, from the basis of algorithm design to the more advanced techniques of dynamic programming and greedy algorithms. We hope that all the presentation has been provided you with the importance of a computer science. Thank you.